The converse of the Pythagorean theorem is used to determine if you have a right triangle, if you have an acute triangle, or if you have an obtuse triangle when you're given the side measures of a triangle. So if you have the three sides, all you do is you plug it into your basic Pythagorean theorem. Like I said on the previous video, we're going to have C on the left side when we're doing the converse. Just think of how the converse is, switching the order of the rule. So we're going to switch the order of the rule, put C first. If C squared is equal to A squared plus B squared, then you have a right triangle. That is the converse of the Pythagorean theorem. It has two corollaries that go with it that say if C squared is less than A squared plus B squared, then the triangle is an acute triangle. And if C squared is greater than A squared plus B squared, then it is obtuse. So less than acute, greater obtuse. Of course, you have to have C squared on the left, otherwise you're going to get these entirely backwards. And then the only ones that you would get right are when they're right triangles. So be very, very sure that you have C squared on the left. So here we're going to apply it, and the instructions say tell whether the triangle formed with the given sides is acute, obtuse, or right. If a triangle can't be formed, write no triangle. The triangle being formed, that is the first thing that you need to check. So you have to check this first, and then you tell whether it's acute, obtuse, or right, which uses a different rule. To tell whether it makes a triangle or not, the only thing you have to do for that is just to add the two short sides and make sure they're longer than the third side. So for checking if this makes a triangle, 5 plus 12 is greater than 13. That is true, so it makes a triangle. But now the question is, what kind of triangle does it make? So now we're going to plug it into the converse of Pythagorean theorem, put the 13 first, so 13 squared. How does that compare with 5 squared plus 12 squared? So it's always the biggest one on the left there. So 13 squared is 169. And then when you add together 5 squared and 12 squared, you get 169. So since these are equal, it is a right triangle. The biggest thing people forget to do is they forget to check whether it's a triangle. The second most common mistake is people not squaring it and just plugging it in like a C and then an A plus B. They get it confused with checking if it's a triangle. On question number 2, we've got the square root of 8. For me to check if it's a triangle, I first approximated the square root of 8. It's 2.83 if you plug that in your calculator. If you add 2.83 and 4 together, you get more than 6. So it makes a triangle. So I like to put, triangle check mark. I checked. It does make a triangle. Now we got to find out what kind. Now that I know what the square root of 8 is, I know that 6 is the longest side. So I put 6 squared on the left. I put the square root of 8 squared plus 4 squared on the right. When you square a square root like this, it just gets out of the root. So that's just 8. Square root of 4 is 16. And then 6 squared is 36. So this one ends up being 36 on the left and 24 on the right. Since 36 is more than 24, this is an obtuse triangle. Number 3, 20 plus 21 would give me 41. That is greater than 28. So yes, it makes a triangle. So now 28 is the C because it's the longest. So 28 squared, 20 squared, 21 squared there, plugging it into the converse of the Pythagorean theorem. On the left side, we get 784. On the right side, when we square these and add them together, we get 841. 784 is less than 841, so this is an acute triangle. So those are kind of the 3 basics. We're not going to do all of these samples together. I'm trying to keep this video short, so I'm going to go to number 7. On number 7, I just wanted to show you how when you add up the 10 and the 12, you get 22, which is less than 30. So no triangle can be formed here. So it can't be acute, right, or obtuse because there can be no triangle whatsoever. It's a little bit like a trick question here, but it was in the instructions checking whether it makes a triangle. And if no triangle can be formed, write no triangle. So always watch for that. That can come up anytime.